Hello Year 5, it's Mrs Gill here for Week 3 Monday's maths session. We're going to begin today by continuing with our mental maths work and looking at the skill of rounding and adjusting. Now last week we looked at adding 9 to numbers and adding numbers which were close to the next 10 to numbers, and this strategy was called rounding and adjusting, and we also started to apply this to subtraction. So let's just have a quick recap of what we did last lesson. So for example, we looked at this number 56, take away 9, and we noticed that 9 is obviously very close to 10. So our first calculation was 56 minus 10, which gave us 46. But because we had taken away one too many, we had to add 1 back on. So the answer was 47. 56 subtract 9, 56 subtract 10 is 46, 46 add 1 is 47. We then looked at starting to apply this to larger numbers close to the nearest 10. So our second example here, we've got 56 subtract 29. Now we realised that 29 was very close to 30, it was only 1 away, and it would be much easier to do 56 subtract 30. I know that 5 tens subtract 3 tens is 2 tens, so 56 subtract 30 is 26. And because I've taken away 1 too many, I need to add 1 back on. So we're going to extend that today by, again, looking at the strategy, but using possibly some slightly larger numbers, maybe closer to the nearest 100 and the nearest 1,000. So let's just do one more recap here. So we have 56. We can see that 19 is 1 away from 20, so let's take away 20 from 56, which leaves us with 36, and we've obviously taken away 1 too many, so we're going to add that 1 back on. That gives us the answer of 37. Slightly trickier here, spot the change. We're now looking at how this number is 1 away from actually 200. So we're going to do 2,388, subtract 200, and I can see I've got 300s here, so 300 subtract 200s will give me 100, so I'll have 2,188. And finally then down here we can spot the change again. This time we're very close to 3,000, but notice we're 2 away from 3,000, so we need to be aware of that as we calculate this one. So we're going to do 7,564 subtract 3,000. 7,000s take away 3,000s is 4,000s, so we get 4,564. Now, as we've said and we noticed, we've taken away there 2 too many this time, so we need to add our 2 ones back on, giving us the final answer of 4,566. We'll just put that answer in there as well. So you can see I've used lots of mental jottings there. We'll just put the final answer in there. And I apologise, I hadn't done that second part, had I? So we've got 2,188. We needed to add our 1 back on. So that's why it's really important, unlike Mrs Gill here, make sure you complete the whole calculation. There we are. So these are some examples. Obviously you can see that I've used my mental jottings. I've shown you out loud my thinking, my process as I've gone through to answer these questions. If you can do it all in your head, fantastic, but it's absolutely fine to show these jottings as well. That's a really good step to take. So what I would like you to do now is, using that strategy of rounding and adjusting, you can decide which column you're going to try, which challenge you're going to try today, and you're going to take the number at the top of your column and you are going to have a go at subtracting the coloured numbers underneath. I'd like to pause the video now so you can have a go at that. Okay, so up on the screen for you now was your answers. If you decided to have a go at another number, if you managed to get another number done in that time, great. If you could use a calculator to mark that for me. Okay, so we're going to begin with our main math session now. We're looking today and continuing with looking at our work we were doing last week on angles to finding missing angles in a triangle. So how will you be successful today? You're going to need to use your knowledge of angles, thinking particularly about what you know about degrees of angles. Use estimation skills and use bar models to represent problems. If I go back to this estimation skills, it's really important because if you have a rough idea of what you think the answer will be, when you've actually calculated, if your answer is miles away, it might make you question and ask you to check back with what you've done so far and see if you can improve and see if you need to just check you haven't made any errors there. So, I'd like you to pause the screen now. We're going to do a quick sort of recap. This is sort of previous learning from year 4 about types of triangles. So I'd like you to see if you can identify, first of all, which of the triangles is an isosceles triangle, which is an equilateral, which is a right angle, which is a scalene. Thinking about how many sides and angles a triangle has, and then some true and false statements about right angles. So if you pause the video there. Okay, so let's have a look at these. Don't worry if you're thinking, oh, I can't remember this from year 4. We will go through it together now. So the first one says, which of these triangles is an isosceles triangle? And I think the easiest way to remember what an isosceles triangle is to think about the fact you have two eyes. Now what that means is in terms of triangles, is that with an isosceles triangle, two of the angles and two of the sides are the same size. So you can see here, this is our isosceles triangle, our two angles are the same and our two sides are the same. And when you see lines like this in the triangle, that actually shows that they are the same length to help you identify that isosceles triangle. The next one then, an equilateral triangle, is a triangle where all the sides and all the angles are the same length. So that's right, we're looking at this one here. And next up then, right angle triangle. If I have a little look here, I can see that I've got my right angle triangle here. And finally then, a scalene triangle is a triangle where all the sides and all the angles are a different size. So if we have a look at these final triangles, a bit tricky to see, but it's this one here. All the sides are a different length and the angles are different too. So let's complete the sentences. A triangle has, excuse me, just sneezed. A triangle has 3 sides and 3 angles. And finally then, with a right angle, has 1 right angle. Is that true or false? A right angle triangle does indeed have 1 right angle. Does it have 2 right angles? Well, it doesn't have 2 right angles, and this is a piece of information that's going to really help us today. It doesn't have 2 right angles because angles in a triangle equal 180 degrees. And if 2 angles in the triangle are both 90, that already makes 180 degrees, and there's still a further angle. Could the 90, so we've got false there, could a right angle be a scalene triangle? Well, yes, actually, if all the sides are different lengths, and actually it could be argued that this one here is a scalene triangle. It has got a right angle, but we can see the length of the sides are all different, so that one could be true. Could it be an equilateral triangle if it has a right angle? And the answer is no, because if you've created a right angle, you need 3 right angles in your triangle, because an equilateral triangle is where all the angles are the same size. So that one would be false for that one, because 3 right angles is 270 degrees. And actually we've talked about the fact that angles in a triangle total 180 degrees, and this is going to be the key piece of information that you are going to need today to help you with your work. So you might need to keep coming back to this. Angles in a triangle always total 180 degrees. Okay, so we're going to look at this first triangle. Now, we need to think about what we know. What have we been told about? Well, we've been told about 2 angles. So we can first of all at least think about, can we work out the total of these 2 angles before we find this missing one? So the first thing we're going to do is we're going to add together 60 and 70. And thinking about the fact we know 6 tens add 7 tens is 13 tens, we've got here 130. So in our first bar model, the representation of 60 and 70, the total gives us 130. Now we need to remember then, if we're going to find this missing angle, that actually all three of these angles are going to total 180 degrees. If I've got the two angles that I know about, which is 130, we need to think about what we're going to do in order to find this missing angle. And this is where our bar model is really useful, because we know we are missing part. So therefore need to do 180, subtract 130, and think about the answer, which is going to be 50. So our missing angle is 50 degrees for that one. And you can see there's going to be two steps today. You're going to need to add the angles you know about and subtract from 180 to find that final angle. Let's have a little look at this one then. So we've got our two angles, so let's find the total of our two angles to begin with. 39 and 31. Oh, I can see a nice number bond there. And 3 tens and 3 tens is 60. So 10 and 60 is 70. So my total is 70 from adding together 31 and 39. So angles in a triangle equal 180. The part that I know about is 70. How am I going to find that last angle? 180, subtract 70, nice easy one, is 110 degrees. So we've got 110 there. The answer being then that missing angle is 110 degrees. Now then, let's have a look at a slightly harder one. And if yellow group at this point you'd like to get on with your work, you most certainly can, or watch this one if you like. Now, if we go back to the properties of an isosceles triangle, this is an isosceles triangle, and you'll know it will be an isosceles triangle because it will often have these two lines to show that they are the same length, sides and angles. So if we know that this bottom angle here is 74, this angle here must also be 74 degrees because they are the same, and we're left finding this missing angle. So once again, let's find the total of 74 and 74, find the total of those two angles. I know 70 and 70 will give me 140, and 4 and 4 will give me 8. So that's 148. Representing it in my bar model, I've got 74 and 74. So now I need to think about the fact that my total angles in a triangle equal 180, and I know that the total of two of my angles is 148. So once again, I'm going to do 180, subtract 148 this time. Subtract 100 leaves me with 80, subtract 40 from 80 leaves me with 40, and subtract 8 from 40 leaves me with 32. So that missing angle then is equal to 32 degrees. And this one's a little bit trickier, but actually by using the properties of a triangle, we were able to solve it. And another one where we need to use properties of a triangle. Have a good look at this one. We've been given one angle. Is there any way that we know the size of this angle? What type of angle is it? Thinking back to last week, absolutely correct. It's 90 degrees because it is a right angle. So actually, we're left finding this missing angle. So let's do this again. We're now finding the total of two of our angles. We've got 90, add 34, which gives us 124. 90 add 30 is 120, add 4 is 124. We know then that the total of angles in a triangle is 180, and we know about 124. Now I don't mind how you calculate today. If you find column methods to help you, that's absolutely fine. If you want to do it mentally, you can do as well. So finally then, my final workings, 180 subtract 124. I probably do this one in my head, so I take away the 100, leaves me with 80, take away the 20, leaves me with 60, and 60 take away 4 is going to give me 56 degrees. So the answer for that one then is 56 degrees. At this point, yellow and green group, if you'd like to get started on your activities today, blue group, you might just want to have a little look at this one, which might come up a little bit later. Now then, I'm going to start with the image down here, and I want us to think about what does this mean. So let's have a look. Look at the diagram, calculate the size of angle X and angle Y. What knowledge do we have to help us? Now I asked us to start by looking at this image down here. What do we notice that these two angles, 35 degrees and Y, are on? Well, they're actually on a straight line, aren't they? So actually, if we have, apologies for my rough bar model here, if we have 180 and we know about one of the angles is 135, we can find Y by doing 180 subtract 35, which is equal to 145 degrees. So we've got 145 degrees. So what we're going to do there is say Y is equal to 145 degrees. Now let's have a little look at X. Well, we can see that X is within our triangle. We know one of the angles in our triangle is 35. And once again, noticing this image here, we can see we have a right angle of 90 degrees. So once again, we've got our 35 and we've got our 90. So add those together, we've got 125. And so once more, we know two of our angles. So draw that bar model again. We know two of our angles total 125. So now what we can do is 180 subtract 125 leaves us with 80, take away 20 is 60, take away 5 is 55 degrees. So therefore, angle X is equal to 55 degrees. You can come back through to this video at any point and pause on any of my inputs you'd like repeated. We look forward to seeing your work today. Thank you.